Welcome. Today, I'm going to discuss that other name reactions related to the carbocations. Previous class, I have discussed about up to name reactions that are related to carbocations. So, third name reactions that is related to carbocation is damage of rearrangements. Okay, and although this type of rearrangement name reactions, it is not necessary to memorize, but we should know the concept that what is happened in case of damage of rearrangements. Okay, so in case of damage rearrangement, what is happened is it may be given any amine groups. Let's say CH3, CH2, CH3, CH2, CH2, let's say NH2. Amine group is there. And what we have that reagents may be it given that HNO2 or this may be written as NaNO2 plus HCl. Okay, any reagents will given HNO2 or NaNO2. Actually, this HNO2 is prepared from this NaNO2 plus HCl. Okay, like I can say that NaNO2, this is positive and this is negative, and plus HCl. Then what will happen? This is positive and negative, so that is going to be replaced. So that is going to be HNO2 plus NaCl. So likewise, you can prepare this HNO2 from this. It means that what I want to say that whenever you write HNO2 means here acid is also there. Okay. Or you can write that preparations of HNO2 is that you write that NaNO2 plus HCl. Then what will get that NO2 plus NaCl. Okay, so this is also very important because you should know that here acid is also there. Okay, sometimes instead of HNO2 they may write NaNO2 plus HCl. Then also uh, that answers products will be the same because from here only we prepare that HNO2. Okay, it means that whenever I write HNO2 means here acid is also there. Okay, and let's say this is that aqueous. Okay, so what we get here, this HNO2 here, it means that this is OH and this is NO. Okay, this is actually OH and NO. And here what we have that acid is there, and acid means that what I say that this will actually protonate to H plus and Cl minus that I have talked about in the chemical equilibrium also, that strong acid they are usually dissociated to H plus and Cl minus. Acid is there, and here what we have that lone pair is there, and this lone pair what will do that it will attack to this protons, and what will get here, okay, what will get here, this NO and this is O, here H, one lone pair is attacked H, and here we have that positive charge, and this water is a good leaving group so that it will leaves, it will take this lone pair of electrons and it will left, it means that minus H2O. Then what will have, this NO plus is there because this take the electrons and leave water. Okay, so NO plus is there. Now what will happen here, the lone pair electron is there in case of amine, and this amine actually attack to this NO. Okay, this is the mechanisms of the Demjin rearrangements. This is the mechanisms how that Demjin rearrangement will happen. Okay, so what will happen here? This is going to be CH3 CH2 CH2 here, and here we have that hydrogens, here we have that hydrogens, and one lone pair attack to this NO, and NO is actually written like this. Okay, and since this lone pair is attacked, so this is going to get the positive charge here. Now what will happen? Now what will happen after this? Uh, Here we have that lone pair electrons, and since this is the positive charge, so it will take this this bond electrons towards itself, and here proton is there, and this proton is attacked by this lone pair of the oxygens. What will get here? CH3 CH3 CH2 CH2 CH3 CH2 CH2, and this is going to be N, and this is going to be the H. This proton is taken by oxygen, so N, and since lone pair of oxygen is taken, so this is going to be the positive charge. Okay, this is what had happened. Now what will we see that this oxygen and nitrogen, since oxygen is more electronegativity, if you check the electronegativity, oxygen is more than nitrogen, and more oxygen is getting positive charge, so this will take this electron toward itself because it is the positive charge, and oxygen get positive charge, and oxygen is more electronegativity than nitrogen, so this oxygen will take this electrons towards itself. So what will get here? CH3 CH2 CH2, and this is going to be N, let's say H here, and this N, and this is going to be the O. So yes, here H is there. Okay, this H is taken by this, so that's why OH is there, so this is going to be the OH. Okay, because this lone pair take these electrons, they take these protons, that's why here OH and positive charge is there. Okay, now this take this electron, so this is going to be the NOH, that positive charge has removed. But what you see that here we will get the positive charge. Okay, now what will happen? Here that lone pair electron is there because this positive charge is removed by that nitrogen take this electron, so this is here the lone pair is there. Now since this nitrogen is getting positive charge, so this nitrogen take this lone pair electrons here, so what will happen now? Going to be CH3 CH2 CH2, and this is going to be the N, here H, since the lone pair electron went to this, then that is going to be the positive charge here, and now this, since this lone pair this lone pair electrons comes to, becomes double bond, so this becomes double bond, and this N, and the positive charge is removed from this nitrogen, this is going to be OH. Okay, now what will happen that this nitrogen again get the positive charge, so okay, since this nitrogen get again the positive charge, so what will happen that this again take this electrons towards itself. Okay, and this oxygen again it will take this protons to it, the same step it will be repeated. Okay, then what will happen here? CH3 CH2 CH2, then this N. Okay, so since it take this lone pair electrons towards itself, so this bond electron between NH that is taken this, that is going like this, and this is going to be this N, and this is the OH, and this is H, because this take this again it will get the positive charge. So now what will happen that Since water is a good living groups, now this water will live, okay, by taking this lone pair electrons. Then what you will get here? That is going to be CH3, CH2, CH2, and this is going to be N, double bond N, lone pair, double bond N. Okay, here we will have that N positive charge. Again, this lone pair electrons will take here. Then what we'll get here? That is CH3, CH2, CH2, and this N, this is going to be the triple bond, and here we will have the positive charge. Now what will happen that, this is the nitrogen gas, that is N2 gas, and N2 gas is a gas. It means that is a thermodynamically stable. So what will happen that this will release by taking this lone pair electrons. So this is going to be the CH3, CH2, and so what we'll get here? CH3, so this is going to be okay. So this nitrogen gas is released. So sorry, the pen. Okay, thank you. Okay, so that will release. So that is going to be that CH3, CH2, and CH2 positive charge, because this nitrogen gas has released by taking this lone pair electron, and we will get this. Okay, so here what will generate that carbocations, and now this carbocations, what it will do that, since this is the 1 degree carbocations, so this is actually, this groups is actually what, this is CH3 and this is C, and two H's are there, and here we have that CH2, and this is the 1 degree carbocation. So 1 degree carbocations never happen the reactions, so either it will shift to 2 degree or 3 degree. Okay, so here it is a nucleophilic mediums, because this is aqueous acid, it means that water is also there. So what will happen now? This hydride will shift, because we know that migratory aptitude, but you know that first hydrogen, then phenyl, then alkyl groups. Okay, so here that hydrogen is there, so hydrogen will shift here. So that is going to be that CH3, C, H, and here we will have that positive charge, and it is going to be the CH3. And now since water is there in the medium, so water will attack. So the product will be going to be that CH3, E, H, and here water will comes here. This is the positive charge, and this is going to be the CH3, and this is going to be like this. So that is going to be the CH, CH3, and this is going to be OH, and this is going to be CH3. Okay, so this is the final product for this questions. So for this type of thing, so this is the mechanisms of the damaging rearrangements. Although these mechanisms no need to we have not to do all the times. Actually, the shortcut is that whenever you see that any groups you have, let's say any groups is there, let's say NH2 is there, and with that any group is there. Okay, it may be any groups, and if you have that reagent, that is HNO2, or that may be NaNO2 plus HCl is there, then what you will do that, simply release this NH2. Okay, simply release the N2 gas. That how it is released, that I have explained. Okay, that simply release means that whatever that, let's say a carbon is there, whatever that carbon will be there. Let's say this is the group is C, and here we have that NH2, and here we have some group is there. Okay, that is nitrogen gas will be reached and the carbocations, and with that here some group will be there. Okay, now we will do the rearrangement. We know about of the carbocations, that rearrangement will happens. Okay, this is the shortcut of the Demgen rearrangements. Okay, so this ammonia will be converted into the nitrogen gas, and that nitrogen gas will be released. And what is the driving force for these reactions? Driving force. Driving force is that releasing of the nitrogen gas. Release of N2 gas, because this is thermodynamically stable. Okay, that is the driving force for these reactions. So this way we can solve. This is the mechanisms of that Demgen rearrangements, how that nitrogen gas will be released. And so whenever you see that in a reactions NH2 is there, and with that reagent HNO2 plus or NN2HCl is there, then simply release the nitrogen gas, because that nitrogen gas is releasing means that its randomness will be increased, means that is thermodynamically more stable products will form. Okay. So what is seen in these reactions, that is we no need to repeat these mechanisms all the times. So what you seen here, that whenever in a groups, let's say this R groups is there, and we have that C, and we have that NH2, CH2, and we have that NH2, and if you have that reagents HNO2, or it may be Na2 plus HCl is there, then what happened, that always it will release that nitrogen gas. Okay, then we will get that this carbocations. After that, we know that after formation of carbocations, that rearrangement will happens. Okay, and do the rearrangements, and after that water will be attacked, because this is the aqueous medium. Okay, so that is the main things about of this Demgen rearrangement. And what is the driving force for these reactions? Driving force is the release of nitrogen gas, which is thermodynamically stable, thermodynamically stable. Okay, so this is about of that Demgen rearrangements. So whenever you see in any reactions, if nitrogen is NH2 is there, and with that reagent is HNO2 is there, just remove that nitrogen gas. Okay, just remove that nitrogen gas and form the carbocarbons and do the rearrangement. When carbon form, then rearrangement will happen. That I have explained in the previous class how you do the molecular rearrangement. Okay, so by solving examples, you will get more clear. So in this whole examples, we will not do the mechanism, we will just do the shortcuts, and we will solve the answer. So whenever you get, just do the shortcuts. That is for understanding. I have explained the mechanisms. So for this case, what happened, that this nitrogen gas is there. Okay, so HNO2 is there. I'm not going to do the mechanisms again and again. So what will happen, we do the just shortcuts. So means NH2 is there and HNO2 is there. Then what happened, that nitrogen gas will be released. It means that is going to be like this. Okay, here we have that CH2 and this is going to be the positive charge, means this is just released, not NH2, the nitrogen gas will be released. How this is converted into nitrogen gas, that I have explained. Okay, so that is going to be the CH2 carbohydrates. Now what will happen, the rearrangement will happen. This is the 1 degree carbohydrates. Okay, and it is the 1 degree carbohydrates, and in 1 degree carbohydrate reactions will not happen. So when in the ring cases, what I've said, that always do the ring expansion. So reason is that angle strain is there, that I've explained in the previous classes about of that rings. If cyclic, then what type of molecular rearrangement will happen. If non-cyclic, then what type of molecular rearrangement will happen, that I have explained in the previous classes. Okay, so here what we will do, we will do the ring expansions. Yeah, because this is the 1 degree carbohydrates. Okay, and here also the chances is there, here hydrogen is there, we can shift the hydrogen and we can pop this one also possible. And this carbohydrate, and this is the 3 degree carbohydrates, but this will not happen. The reason is that for cyclic cases, if this is 4 member ring, then angle strain is there, then always it first preference is to do the remove of the angle strain. Okay, that I have explained clearly in the previous class. Whenever in a cyclic, then always first preference you will do that whether angle strain is there or not. Okay, because for a carbohydrates 120-degree angle is needed. So what I will do, that I will do the ring expansion. So this is 1 2 3 4 and 5. Okay, and this is positive, then let me make that bond 2 here. So positive negative make bond, and this is negative, then if I looking these bonds, then this is going to be positive charge, that I have also explained in the previous class. Okay, so then what will do, that 5 member ring will pop. Okay, so this is going to be that so let me one, this is 3 1 3 will make bond, so 1 3, then 4 5, and this is going to be 2, and 2 will get in the positive charge, so make here positive charge. Okay, and 2 also we have that ch 2 has the positive charge, so make it. Okay, so this is what it happened. Now what we will do, that water is there, so water will attack to this positive charge, so we will get the product as this one, OH. So this is the final product for this question. So if you are confused about of this ring expansions, please look my previous class, that I have explained that how this ring expansions will happen. So this is we will just give the names, and we will make that positive and negative charge, because bond means positive and negative. Okay, now moving to the next questions. Here also what happened, that here nitrogen gas is there and HNO2 is there, so just remove that N2 gas. Okay, so this is going to be that, this will be removed, it will make NH2 will pour and nitrogen gas, and after that it will release. Okay, so we will get here this type of things here, because this is release, so this is going to be the positive charge here. Now what will happen, that here ring expansions to 5 member ring is not possible here, because carbon itself is that carbon itself is 4. Okay, so we can't increase to a 5. So what we will do, that then 4 member ring is unstable. Okay, so from here what we can, that we can reduce this 4 member ring to 3 member ring, because stable rings, stables are 3 member ring is more stable than the 4 member rings. Okay, so from these 4 member rings we can reduce to the 3 member rings. It means if it is positive, then I can make here negatives, so that I will make the bonds, and here negative means this is going to be the positive. So what I will do, that I will make here 1, let's say 2 and 3 and 4. So 1 3 4 I am going to make the bonds. Well, this is 1 and this is 3 and this is 4, and this bond has break, this has break, and this has 4. So here that is the 2 is there, and this is the CH2 and this is the positive charge. Okay, because this 1,2 bond has break. So that ring expansion things I have explained in the previous class. Okay, so this is going to be like this. Now what will happen? Here after that water is there, so water will attack. It means that is we can write this one also like this. This is going to be CH2OH. So this is the final answers for this type for this questions. Okay, so this will not go to this is the ring will be decreased to a 3-member rings. Same case in these examples we can solve it that here HNO2 is there and nitrogen is NH2 is there. So first our duty is to look that NH2 is there or HNO2 is there. If that is there, just remove that nitrogen gas. Okay, so that we are going to get here is RC R, this is OH, and this is going to be the CH2, and this is going to be a positive charge. Okay, so now what will happen that CH2 is there, so now that rearrangement will happen. So this is not a ring, so I have told that if it is non-cyclic, then how we will do the molecular rearrangement. So here that migratory aptitude we will look. So migratory aptitude, that is H, then phenyls, then alkyl groups. Okay, so here H is not there, pH is also not there, R is there. So if you get confused about of that whether I will shift OH or R, then just do that. Migratory aptitude is actually from this migratory aptitude H came. Okay, so if you confuse about of this migratory aptitude, then just do both the possible products. If I shift R, then what will happen? If I shift OH, then what will happen? Let's say R if I shift 1 and 2 if I shift OH if I shift 2. So let's say this is 1 and let's say this is the 2. So if I shift the R, then what will happen? This is SC and I shift that R, positive charge, here R and here OH, and this is going to be that CH2R. Okay, now if I shift OH, then what will happen? That case also let's look, C R and R, this is point positive CH2OH. So which is more stable to carbocations? So here what is that? Here this carbocation is stabilized by 6 alpha hydrogens because R means CH3. Okay, but here that carbocation is stable by close effect. So now you tell that which is more stable. So this is the more stable. So this will not pour, this is going to pour here. Means what will occur here? That methyl shift will occur. Okay. So this migratory aptitude is nothing but to shift both the cases which is more stable, that will form. That is what they actually mention, that migratory aptitudes. Okay, so now what will happen? Now water is there, so water will attack. Water will attack to this, then that is going to be R, C, here OH, and this is OH, and here we have that CH2 and R. So note that at 1 carbons, two OH group not stable. Okay, this will never pop. So at 1 carbon, two OH groups we will never never see these things. Okay, what will happen here? That water will be released. It means this and this is going to be released, and this is going to be here. That is, water is released here, and what will get? This R and this is a double bond O, because this went to here and this is going to be the CH2R. So this is the final product for this questions. Okay, so likewise we will solve the question. So at 1 carbon, two H groups, never we will see that one. Okay, this is not stable, so water will be released here. Okay, likewise we can solve these questions. Now moving to that last questions for that Damgene rearrangement, means likewise you can solve that a lot of questions. Okay, so this CH2 NH2, this one also we can write that CH2 and N means that I told double bond, triple bond, N. Okay, and 2, that is the gas, that is going to be this one. Okay, and this is going to be negative charge, and this is going to be the positive charge. Okay, so this is the what we see in that nitrogen gas means triple bond, and here we have the positive charge. Okay, so now on this one also you can do that resonance, that is going to be, if I shift to here and if I shift to here, then that same things will happen. CH2, this is double bond of N, this is double bond of, this is N minus, again here we have that positive charge. So now the question is that which will attack. This is that electrophilic centers, this is delta plus and this is delta minus. Okay, so which will attack this delta electrophilic centers? Either this negative charge of nitrogens will attack, or this negative charge on carbon will attack. So now we know that the electronegativity, that is nitrogen is more electronegativity than carbon. So if nitrogen is more electronegativity than carbon, it means that nitrogen hold electrons more forcefully than carbon, because that nitrogen is more electronegativity, it means that it need electrons. So even if it has negative charge, it will hold more than the carbon, because carbon is less electronegativity, so it will not able to hold as much as nitrogen will hold. So which electrons are free? That is carbon electrons are free, because that is not able to hold that much, whereas nitrogen is hold more, because electronegativity. So what will happen now, that this negative charge will attack to this one. So what will get here? Okay, so this is going to be that O minus, and here we will have, so this will attack. Okay, this not attack. So here we have that CH2 and this N triple bond of N, and this is positive charge is there. Okay, so this negative charge is neutralized after attacking this one. So now what will happen? This nitrogen gas will release, N2 gas will release. Okay, so this is the same things that things like HNO2 and NH2 and HNO2, they are also used to form that nitrogen gas. Here also that it is given like this, so that nitrogen gas will release. So what will get here? The same things, that is here O negatives, and here we have that CH2 positive charge. So now what we will see that here we can do the ring expansions. Okay, here the chances is we can do the ring expansion, that I previous class I've said that 5 member ring is more stable than 6 member rings. Then why are doing the ring expansion? See that 5 member ring, 6 member rings, they always interchangeable, but 6 member ring, 5 member ring is little more stable than 5 member ring due to that ring constructions. But if ring expansion chances there, we can do the ring expansions. So what will happen, that 1 2 3 4 5 and 6. So I want to make that 1 3 bonds, or we can make this one 1 6. I want to make the bond. So let's say this is negative, then this has to be positive, and this positive negative make bond. So make this 6 member ring. Okay, and name that this is 1 2 3 4 5 and 6. So 6 is 6 1 6 make bond, then 2 will get the positive charge. Okay, now water is there, so that water will attack, this. So then we will get that this. Okay, so just a minute. After that 2, in the 2 O minus is also there, so water will not attack this negative, the positive charge, and O minus is also there, and we know that this positive negative make bond. So that means this is what to be simply this one. This is the product, because here what we have, that positive charge has popped at that 2, and here negative charge is also there, and we know that bond means positive and negative, so that's why this will make bond, and this is the final product. Okay, so likewise we can solve the questions related to the Dam-Geneva rearrangements. So only not that in Dam-Geneva rearrangement, the driving force is the releasing of the nitrogen gas. Okay, and whenever you see that NH2 and the reagent is NH2, always release the nitrogen gas. Okay, so this is the about of that Dam-Geneva rearrangement. So in that we no need to remember that name of the reactions. We just know the concept that whenever NH2 is there and HNO2 is the reagent is there, just remove the nitrogen gas and carbon will forms. And we know that if that is a ring for member ring, if ring expansion is there, always first priority of our work is to do the ring expansions because carbocations need that 120-degree angles. Okay, so that's the very important is that first do the ring expansions if any chances is there. Okay, yeah, whether that is 3 degree 2 degree, that does not matter if ring expansion chances is there. So that things I have explained in the previous class also. So moving to that next name reactions, that is dienone-phenol rearrangements. So this is another name reactions related to the carbocations. Okay, so here what we see that here from this dienone-phenol rearrangement, so memorizing the name of the reactions play a little important rules for this case, because in the name reactions itself it says that what is the reactants and what is the products. Okay, so dienone-phenol rearrangement. So we know that what do you mean by di means we know that that is 2, and in means we know that that is double bond. Okay, and on means we know that that is the ketone group, and phenol is there, so we know that is a phenol. Phenol means phenyl ring will be there. Okay, so this is the about of that what that the name reaction says. Okay, so di-in on, so this is actually the substrate, this will be the substrate, and this is going to be the product. So from that name reactions itself we understand that what will be the substrate and what will be the product. So memorizing this name reactions gives little bit benefits, because from this name reactions we will understand that what is the substrate and what is the product. Okay, so what we see here, di-in-on. So di-in-on means that this ring is there. Okay, these things will be present here, and what will have that di means 2 double bonds will be there, 2 double bonds, and on that what that ketone group is there like this. So always if you see that this type of substrate, it means that ketone is there, with that to this double bond conjugation to this 2 conjugate double bonds are there, means this also conjugations with this also conjugate with this things is present, then this type of substrates then always make that phenol. Okay, the product will be always phenol, and that what will be the reactions conditions for this? Reactions condition is acidic medium. Okay, let's say H plus or any acidic medium is there, and if this type of substrates you will get. Okay, if the ketone group is there and to that 2 double bonds are there in between, in the middle of the carbon, that ketone group is there, on that case always form that phenyl. Okay, here what is the driving force? Driving force is that forming aromatic ring. So driving force is that here aromatic ring will form. Okay, so what how that reactions will proceed this one? So here we have that lone pair electrons, and this lone pair electrons attack to this H plus. So what we will get here? So here in these reactions the important things is that remembering these substrates. It means that ketone group is there in the middle, and to that adjacent 2 double bonds are there, and these 2 double bonds are in conjugations with this ketone groups, then always these reactions will happen, dienone-phenol rearrangements. Okay, so what here we get, O, and this is H, and this is going to be the positive charge because lone pair electrons attract to this one, and this is the two. This is the two double bonds are there. Now what will happen? This oxygen will, because oxygen is more electronegativity, this will attract electrons towards itself. Then this is going to move here. Then what will get? OH, and this is going to be here, and this is there, and here we have that positive charge is there. Okay, so now what will happen? Since here we have that hydrogen, this hydrogen will shift here. Okay, that eliminations will happen. Why? Because that we are getting aromatic reactions, so this is the past reactions. So what we will get here? Here we have that OH, this and this. So we will get that vinyl ring. Okay, so this is the product. So and this is the very fast reaction, and it is the more stable product will forms. So this is about of that dimer phenol rearrangements. Okay, so what we will see that this will attack to this, and this will shift, and this will we will be the make the product. So in this reactions, the important things is that we has to remember these substrates. Okay, whenever two double bonds and in between that have that ketone groups and medium is acidic, then always form that vinyl ring. Okay, that is the very important for this name reactions. And here that driving force is that we are getting that aromatic ring. Times it is. Okay, now we will show that some examples related to this dimer phenol rearrangement. Let's say that same examples here. What will happen that this will attack to this. So what we will see that first we will look that whether ketone group is there, and with that two double bonds are there, and these two double bonds should be conjugations with that this ketone group. So in this way we can identify that whether this is dimer phenol rearrangement or not, and medium has to be acidic, and then we will directly form that vinyl rings. Okay, so like that we can solve the questions. Moving to the next questions. Here what will happen? That same things. This is attack here. So what we see that two double bonds are there with that ketone group is there in the middle, and this both are in the conjugations. It means that we will do the dimer phenol rearrangement. Means phenol ring will forms. But here a little bit has to do that. Let's say this one. This is going to O. This is a positive charge here, and this one, and this like this, and here we have this 5-member ring. So now what will happen that this is shift to here, and this is going to shift here. Then what will we get? That is going to be OH, and this, and this is going to be positive charge. Now what will happen? Here that eliminations will not happen, since that this carbon, no hydrogen is there. Okay, so here no hydrogen. So direct eliminations we can't do. And what we can do that here ring expansion is there. This is 5-member rings. So this can be converted into the 6-member ring. So do the ring expansion. 1, 2, 3, 4, 5, and 6. And let's say this is negative 1, 3. I will want to make bond negative. This is negative, then this has to be positive. Okay. So that I can do the ring expansions. and here I'll do the ring expansions. Here we have OH and this and this, and 2 will have the positive charge. So this is 1, this is 2, and this is 3, this is 4, this is 5, this is 6. So 2 will have the positive charge. Okay, now what we'll do that, here in this case 1 2 3 here, yeah, okay. So here what we have, that hydrogen is there, because one carbon there only 4 will form. So 3 are the methyl, but then 1 is left, so that has to be hydrogen. So then now we'll do the eliminations, and this is the past reactions. Okay, this is the eliminations, because aromatization is happening. Okay, or you can write that aromatization. So what we'll get here, this one, and here wedge. What we see that we will get the phenyl rings. Okay, so this is that's why it's called the dienol phenyl rearrangement. Next, moving to the next questions. So whenever in the junctions, at this junctions, if we have the ethyl, then what will do that same it will happen, that will attack to here, because first our work is to look that in this double bonds whether both are in the conjugations or not. Then only dienol phenyl rearrangement will happen, and medium should be acidic. Okay, so then that all the conditions are satisfied, so we can move like this, and this is OH, this is positive, this and this. Now what we'll do that, wherever the this ethyl is there, that will shift, this will shift, we will not shift this one, we will shift this one, because at the acidic medium. Okay, this is the acidic medium, and acidic medium, and let's say this is at the aqueous solvents. Okay, if it is aqueous solvents, then we will do that, you have to shift this one. And if it is non-aqueous solvent, then we will move this one. That type of question is also there, that we will solve. So now it says this is aqueous solvent, now we will move this double bonds. Okay, if it is non-aqueous, then we will move this one, but here we will not move since this is the aqueous solvents. Okay, so what we will get here, so this is going to be the OH, and this has moved to this one. Here we will have that positive charge, here we have that ethyls here, and here this charge is there, this double bond is there. So now what will happen, 1 2 3 4, so no hydrogens, so this ethyl will shift here. Okay, that is ethyl shift will occur. So what will get, so here we have that ethyls and this, and here we have that OH, this is there. Okay, and here we will have the positive charge. Now what we've seen that here hydrogen atom is there, because 1 2 3 4, and now here that eliminations will occur to get aromatization. That means that we will get this product. So here we have that OH, and here this one. Okay, so what product we will get that, this is let's say to this ortho, this is meta, so this will get that meta product. This is means that that is what I said, that phenyl rings, that is the meta products we will get. So we will next when solving to these questions. So in this case, how we will do that, same, that both the conditions satisfied, means that two double bonds are there, and with that ketone group is there, and both are in the conjugations, so we can do that, and diene phenyl rearrangement. So no need to remember diene phenyl rearrangement. What we look at, we have to look at the concept that the ketone group is there, and both the sides ketone, the double bond is there, and that two double bond has to be conjugations with this CO groups. Then we will do that. This we will form the phenyl rings. Okay, that we have to remember. memorizing the name of the reactions is not necessary if you know the concepts. Okay, so what to do that? Then this is going to be OH. This is going to be positive charge, and here we have that methyls. Here we have that ethyl. Then what will do? We shift this, and this going to be like this. Then that is going to be the OH. This here we have that positive charge. Here we have that methyls, and here we have that ethyls. Then what will happen? Now that here also no hydrogen is there, so elimination is not possible. So we have to do that aromatizations. So sorry, I have to do that migratory aptitude. So what will do that? Which will shift either methyls or ethyl. Here elimination is not possible, because no hydrogen atoms. Now the question is that why not you do eliminations here also? It means that water is there, water will take this methyl. That is not possible. Hydrogen is there, then that water will take that hydrogens, and that it will do that elimination reactions. But here that part of hydrogen is not there, so you can't do the eliminations. Okay, what to do that? Here migratory aptitude will happen. Okay, if water is there, then that will do the eliminations. Or eliminations it can be happen by if you give little heat, also that eliminations will happen. Or here that aromatization is there, aromatization very stable product, so that will happen by itself also, because aromatization is very stable product will form. Okay, so if water is present, if water is not present, if you simply heat, or if the product is very stable, then eliminations happen by itself also. Okay, that we has to memorize it, that we should know about it. So here that eliminations is not possible because hydrogen is not there. Okay, so we will do that migratory aptitude. So migratory aptitude, what I said that migratory aptitude, that is first hydrogen, then phenyls, then alkyl groups. And for alkyl groups, order is 3 degree carbocation past. If 3 degree molecule carbocation past, it will shift. Then 2 degree, then 1 degree. Okay. Or this one also we can write 3 degree. Then if we have cyclohexyl groups, then 2 degree, then 1 degree. Okay. So this is the migratory aptitudes. Migratory aptitude past hydrogen, phenyl, then alkyl groups. For alkyl groups, past 3 degree carbohydrates, then cyclohexanes, then 2 degree, then 1 degree. Okay. So this is about of that. Just to do the questions very quickly. But if you don't know the migratory aptitude, then we have to solve both the products. It means that let me shift past methyls, then what will happen? Let me shift ethyl, then what will happen? Which is the most stable product that will form. Okay, so if you don't know migratory aptitude, make both the cases and check that which is more stable. That is going to be your answers. Okay, and if you know the migratory aptitude, just go as for the migratory aptitude, that will have the final product. So now I'm going to do that both the cases, and I will check that which is more stable. So let's say here I will do that methyl shifts. Here let's say that I will shift the ethyl shift. So if I do the methyl shift, then what will happen? This is OH, and here we have that methyls, and here we have that ethyl, here we have the positive charge. And if I, let me write methyls here, CH3, let me write ethyls here, CH2, CH3. Now if I do the ethyl shift, then what will happen? OH, and here we have that CH2, CH3, and here I have that CH3, and here the positive charge will form here. Because positive charge after methyl or ethyl shift, positive charge is coming to this one. So now we will check that which is more stable. So here we see that this carbocation is stable by 2 alpha hydrogens. Okay, but here the carbocation is stable by 3 alpha hydrogen. So this is stable by 3 alpha hydrogen hyperconjugation. This is 2 alpha hydrogen. Now I will tell that which is more stable. This is more stable. Okay, that's why what you see that ethyl will shift, methyl will not shift. So this will not shift, this will shift. Reason is that here we are getting that here that carbon is stable by 3 alpha hydrogens. So that's what we said that for R groups, first 3 degree, then 2 degree, or that is 3 degree, then cyclohexane, then 2 degree, then 1 degree. So here we see that this methyl is 1 degree, then this ethyl is 2 degree. That's why that ethyl will be shift. Okay, not methyl. So ethyl will shift. So this shift will occur. That region also you see that this is unstable by 3 alpha hydrogens. So now what we'll do after doing the shipment? Okay, so now what we'll see that. Okay, so that ethyl shift will occur. Ethyl shift occur. It means okay. So here OH, this and this. Okay, and here we have that ethyls. Here we have that methyls. Here we have that positive charge. Now what we'll do that. Now you know that here hydrogen is there, so now that eliminations will happen. So now we'll get that aromatizations will occur. This is OH, this, and here we have that ethyls, here we have that methyl. This is the inner ring we get, this is the final product. So likewise, we can solve that questions related to which dienal phenol rearrangement. Now we can solve this question also same way. This will attack here, means that all the conditions satisfied. Okay, so we can solve that the same manner. That is OH, and this is going to be a positive charge. This, and here we have that OH, and here we have that CH3. And now what we'll do that this is going to shift here, this is going to shift here. The same things we'll do that OH, and this is going like this, and here we have that positive charge, here we have that OH, and here we have that CH3. Now what it will happen that methyls or OH. So we don't know about of OH. So what we'll do that if you confuse about micrograph form the both products. So if I will do that OH shift, then what will happen? If I do that methyl shift, then what will happen? So if I do the OH shift, then what will happen? Here OH is there. So here OH will go, and here CH3, and here we have that positive charge. And if I do the methyl shifts, then what will happen? Here OH, and here CH3, and here OH, and here with the positive charge there. Now you tell that which is the more stable product. So this is stabilized by 3 alpha hydrogens, where this is stabilized by plus N impact. And what I said that carbon is more stabilized by plus N than the hyperconjugations. So this will not form, this will form. Okay. After that, what will do that? Eliminations will happen. So here we have that hydrogen, so this. So aromatizations will occur. This is C3 and this is the OH. This is the final product for this. Likewise, we will solve the questions related to that dienal phenol rearrangements. Now, in this way also same things we can solve here. That conditions first we will look that whether condition is satisfied or not. Okay. First, this double bonds has to be conjugated with the CO groups and medium should be acidic. Then what we'll do that we will solve the same way. That is going to be like this. OH and this shift here. This is here we have that positive charge, and here we have that ethyls, and here we have that CO18. Now, if you confuse it, then form the both the products. So if I do that ethyl shift, what will happen? If I do the CO18, then what will happen? So if I do the ethyl shift, so let if ethyls will shift here, and here we have that COET. So COET means COET, and here we have the positive charge. If I COET I will shift, then what will happen? OH, and here we have that COOET, and here we have that ethyls and positive charge. Now you will tell that which is more stable products. In this case, this carbon is there, and this is the electron withdrawing groups. So you understand that electron withdrawing groups. So it will want to take electrons from here, and here itself it is a deficiency. So this is become very unstable. So this will fall stable. So this will fall. Okay. Now after that, here hydrogen is there, so that eliminations will occur. So we will get these products. Here we have that COET, and here we have that ethyl. This is the final product. Now the last questions for this dienal pinner rearrangement. What I've said that whenever you have that aqueous HCl in the sense that is H plus, and medium is water is there in the reactions, or nucleophilic solvent is the nucleophilic. Okay, this is the nucleophilic solvents, or you can say that you can write this is aqueous solvents, because water is there. On that case, what we will do that I have solved this one. Here meta product we will get, that is going to get. So this one I already solved it. Okay, this one. Okay, this one I already solved that. So if it is there, and at the conjugations, if any group is present, on that case, what you get that meta product will be positive. Okay. So at conjugations, the dienal rearrangement is there, and two rings are there. At conjugation, some group is there. On that case, what product will fall? If it is aqueous solvents, then that is going to be that meta products. Okay, so let's say that two rings I will make, and let's say their OH, then this is ortho, then meta. Here we have that ethyl group is there, and this is the dienal pinner. So this will form if it is aqueous solvent. Now if it is non-aqueous solvent, then what will happen? So what I say is that if it is aqueous solvent, then this will shift. I says that this will shift, and this will fall. Now if it is non-aqueous solvent, this acetic anhydride, anhydride means we know that that is water is not there. It means that this is the non-aqueous solvents. So in this case, this will not shift, this will shift. Where? In case of non-aqueous solvents. So what we will get here? In this case, this will shift, this will not shift. Okay. So here here we have that OH, that here also acid is there, H plus, so this will attack to this one, and this, here we have that ethyl, so this is going to shift here, and this is going to be shift here, this positive charge there, so this is going to be OH, and this is going to that, and that this is going to be a positive charge, and here we have the ethyl groups. Now what will happen? So here we have the positive charge. Now here we see that there is no any groups is there, and 1 2 3, 1 2 3. So here we can do easily. So I can do yes, I can do the eliminations, because here positive charge, hmm, If I shift this also I have the problems, because here if I shift that, then that is not going to be a aromatic ring, so I can shift this one. So what I'll do that, I'll just move it to here, I'll just move it to here. Then what I'll get here, this and this. Here I will get the positive charge, and here we have that OH. Okay, now here we have that ethyl groups there. Then here we have that hydrogen is there. Sorry, we can't do that. So what will do that, we will not shift this one, because positive charge is here, right? So we can't shift. So what will do that, because if shift that, some force is there, some force we have to there to shift this one. So we don't have, we have here the positive charge. So what will do that, here we can do the eliminations. So we will do the ring, we can do that, we can decrease the ring. Okay, so that, so 5 member and 6 member there do exchange is no problem. Okay, so we can do 5 to 6 and 6 to 5. So what will happen now, if it is positive, then hmm, this is positive, then I has to make this in, oh okay, all we can do that, this shift we can do first. Then what will get, OH is created here, and here we have that positive charge. Now if we, here we have that ethyl group is there, so positive, and so what will do that, positive, negative, right? Let me do that. So here what will happen, negative and this is positive, we can do that, and this positive, charge is there. Let me make this one again. Okay, so that is going to shift here, that is going to OH, and this shifted here, this is that, and here we have that ethyls. So it is shift from here to here, so here we will have that positive charge. Okay, I was confused about it, here with a positive charge will be there. So now for this, here that we can repeat that, then all are there, so we can do that one. Here hydrogen is there, so what we'll do in this case, just shift to this, shift this one, here we have that OH, so it is shifted to this and this is shifted to this. So here we have that positive charge. Now here we have that ethyl. So now what can I do that? So this positive and this side. Sorry. Actually, here only we can do the ring expansion. Will not move to this one. Here only we will do the ring expansion. So this is positives. Then I can make this is the negatives and this is the positive. I want to make the bonds here. That's what we'll do here. Here we have that OH, this and this is going to be the 5-member rings. And here that is going to be that ethyl, and here you have that positive charge. So now what we'll do that shift to this to that positive charge and this here, then we're going to get this and this. Here we have that OH, and here I will get the positive charge, and here I have that ethyls, and here I have that 5-member ring. So now what we'll do that I can expand the rings. So this is 1, 2, 3, 4, 5 and 6. So this positive and this is the positive. So I want to make the bonds with this. Let's say this is negative, then this has to be positive, so 2 will get positive charge. That is going to be this. Okay, and this here we have that OH is there and this is there, and here we have that ethyls, and this 1 and 6 will make bonds. Okay, so 1 6 will make bonds, and this is 1 6 5 4 3 and 2 will get the positive charge. Now what we'll see that here 1 2 3 hydrogen is there, so this is that eliminations will happen, means aromatization will occur, so we're going to get this product. So here OH, here we have that. So what we see that here we get that para products. So whenever we see that if it is an aqua solvent, non-aqua solvent is there, on that case what we get that we will get that para products. Okay, on that case we are getting that para products. And if it is aqua solvents, then what are we getting that we used to get that meta product. That we has to look it that if it is aqua solvents, then we will make that meta product, because on the time this will shift, and if it is non-aqua solvent, this will shift and we are going to get that para product. Okay, so this is all about of the reactions related to diene phenol rearrangements. Okay, we will solve in the next class other named reactions related to carbon. Today after this, thank you.